Hi everybody, good day. Welcome to join StarlingX project overview introduction. My name is Yong Hu, and I am from StarlingX team at Intel. Well, let's get it started. Here is the agenda for today. Firstly, we will have a quick glance at what StarlingX is about. Secondly, we could look into a bit more in depth with the high-level architecture diagram. The third, we would like to call out some features highlighted on StarlingX. Then we will quickly go through StarlingX project's roadmap along our development journey in past years. Last but not least, we are showing you all the contributors in our community. Okay, let's have a quick look at what StarlingX is from this page. First, when you access StarlingX website at https://starlingx.io, you will see the introduction as such. There are a lot of words, but with that, we could capture a few keywords like cloud infrastructure for edge, no latency, and so on. In summary, we could describe StarlingX with the following 5 bullets. Number 1. StarlingX is a top-level project approved by OSF OpenStack Foundation in June 2020. 2. StarlingX is a hardened Kubernetes implementation, which was certified by CNCF. And it's also an OpenStack instance, which is optional to deploy based on your needs. 3. StarlingX can manage containers, virtual machines, parameters for tenants and user. 4. StarlingX provides a set of DevOps tools to manage cluster hardware, mostly x86 servers, OS, operating system, and cloud infrastructure. 5. StarlingX is optimized solution on deterministic latency and performance for edge computing. Keeping the general description in mind previously we see. So let's move on, having a look at the high-level architecture on this page. On such a software stack, layer by layer, bottom up, on top of 86 servers, we are having a Linux distribution. More specifically, StarlingX integrates CentOS with either real-time kernel or standard kernel. Going up to the user space, we integrate a couple of dozens of building blocks from upstream communities, shown in orange blocks. These building blocks are running on top of CentOS host, which we call it distribution layer. Essentially, they are providing all kinds of services in order to lay the foundation for a cloud infrastructure. For example, IPMI will work with server PMC modules to provide very low-level hardware and software manageability. Ceph is deployed and serves storage for Kubernetes and OpenStack in the backend. etcd is the cornerstone for Kubernetes control plane. Docker is a fundamental part for any cloud-native infrastructure, no doubt. All the building blocks are playing the key role on StarlingX. Above, we just named a few. Moving on, you will notice there are a bucket of blocks in purple: host management, fault management, software management, configuration management, and service management. We call them Flock services, and they are core modules delicately contributed by StarlingX community, other than utilized from other open source projects. For the details of these Flock services, you can check out StarlingX online documents. As well, on this diagram, there are other two subsystems in purple, named Infrastructure Orchestration and Distribution Edge Cloud. Infrastructure Orchestration implements ETSI NFV Vim interfaces by wrapping OpenStack or Kubernetes client APIs. And Distributed Edge Cloud is a solution to fulfill the needs of edge cluster which could exist geographically distributed. With the base on the distribution layer and the Flock service layer, we are ready to boost a Kubernetes cluster. So here we are seeing the blocks in blue. The core part, of course, is Kubernetes. And there are also a few other components which are leveraged to facilitate container images and applications. Up to this stage, StarlingX is having everything in terms of constructing a cloud infrastructure. As said, if there is a need, OpenStack services can be deployed with StarlingX by means of containerization. In another word, from a Kubernetes point of view, OpenStack services are just a bucket of deployments, pods, services, etc., etc. In summary, this diagram presents how StarlingX is integrated layer by layer. Conceptually, hope it's helpful of giving you a whole picture about StarlingX architecture. On this page, we listed a few highlights or features on StarlingX project. First of all, StarlingX is validated infrastructure. In StarlingX, both containers and virtual machines are supported. From storage perspective, Self-Cluster is deployed as the backend for Kubernetes PV and OpenStack services such as Glance, Cinder, and Swift. From hardware perspective, we also had Inter 1 gig 10 gig NIC, TSN NICs, and several other NICs integrated and validated. Also, Inter FPGA and QAT cards are integrated as part of the package. Secondly, for the edge computing use case, no latency requirements. StarlingX take advantage of primitive Linux kernel, KVM, and edge end-to-end tuning, even include TSN integration. Moreover, StarlingX has high availability, more than Kubernetes and OpenStack. Thanks to those features like active standby controllers, synchronized states by multiple layers like DRBD, service management, and process monitoring, and a few other features such as online patch, software upgrade, and backend and restore. All these make StarlingX a more reliable, scalable, and high availability infrastructure solution. From previous pages, we have already known what StarlingX is and its architecture. Now let's see how it's deployed in place practically. With StarlingX, we have 3 deployment options to fit different requirements in terms of resource demanding, capacity, scalability, and high availability. The first choice is Simplex AIO all-in-one on a single server on which there are all 3 logic roles. We also call them personalities, control, storage, and compute worker. This deployment is the simplest way of having a try with StarlingX to know how it works and what it can do, but its lack of the capacity of scaling and high availability. The second way of deployment is called duplex AIO on 2 servers. With the active standby redundant design, we could gain the merits of the high availability, while the actual computing capacity is still very limited because there are only 2 servers, and on each server, all 3 rows are up and running. The last one is a standard solution. Multiple servers are placed and each plays different roles, dedicated roles, control, storage, or compute worker. In such a deployment, we have 2 controllers with active standby pair by design, a couple of storage nodes, and up to 100 compute workers. This multi-node deployment is preferable in the real production environment because it has a lot of the advantages from all aspects. So, these are options we have, and you can choose one of them based on your actual needs. This page, I will talk about our journey along with StarlingX project. Taking the metaphor, we put this project in 3 phases: crawl, walk, and run. First of all, similar to other projects on the OSF, we follow the rhythm of release 2 versions every year. We kicked off this project in 2018 earlier, and we made it join OpenStack Foundation and May Vancouver Summit. Later, 2018, in October, the community made the release 1.0. Moving forward to 2019, we made a leap on the architecture, reconstruct StarlingX from the design with OpenStack directly installed on the CentOS to a design around Kubernetes. With such a huge change, we released 2.0 in September and 3.0 in December with further polishes. In 2020, we made 4.0 with Kata Container Integrate, keeping up with OpenStack Usuri and a few other industrial IoT features, such as TSN, time-sensitive network support, as I mentioned previously. And going ahead, by this year, we will have another release 5.0 with containerized self-cluster by Rook operator. As well, a new personality for the Edge Worker node, which could have previously installed the Linux distribution OS running. Going through 3 years, we are ready to step up to a run stage in next and following years. There, we are going to aim at the ecosystem development with our partners in all edge computing segments. Because we are a part of the Open Infra family, StarlingX community always promotes 4 opens. First of all projects in StarlingX are fully open sourced. Secondly, StarlingX is with open design, as we described on previous architecture page. You can also get more information from the online deck. Then, the development process is hosted on Garage and open for everybody to review and comments. All in all, StarlingX is an open community, and we welcome all kinds of contributions by all means. On this page, here are all the community partners. They are contributors or donors. Here, on behalf of the community, I would like to say thank you for everything you have done for these projects. Last but not least, again, welcome joining us. Then, let's move to the Q&A session. Thank you.